All right, folks, let's go ahead and continue. So the other day, I gave you guys a little head start, and I posted it right away. So it's been a couple of days. It's actually been like a little bit more than 48 hours. So we did 11 and 13 already. So let's go ahead and finish off the rest. So let's start at the beginning, right? Let's start with finding the inverses, right? So it's 11, or so it's 9, 10, 11, 12, 13, 14, 15, 16. So let's start with that first. Okay, so let's see. Nope, can't. Not gonna zoom in anymore. So this is about all we got. Okay, so go ahead. We'll call this y. Then we will go ahead and swap x and y. So we will have x equals cubic root of y minus 3. And we're going to go ahead and add 3. So I'm not going to write in the little steps, but we're adding 3 to both sides. So it'll be x plus 3 equals cubic root of y. Now to get rid of the cubic root, we're going to cube both sides. So take to the third power and then to the third power. So it'll be x plus 3 to the third power. That's going to equal y. So that means that our inverse is going to be h inverse of x. It's going to equal x plus 3 to the third power. Okay. Okay, 10. Let's go ahead and g of x. Let's go ahead and call that y and swap it. So it'll be x equals 1 over y minus 2. Solve for y. So we're going to add 2 to both sides. So it'll be x plus 2 equals 1 over y. All right. Now here's a trick you can do. Right? Because the y is on the bottom, you just flip both of them. So if I flip both of them, I'll get something like 1 over x plus 2. That's going to equal y over 1, which is exactly what we want. We want the y by itself. So there. So we've got this. So the answer for g inverse is going to be g inverse of x. That's going to equal 1 over x plus 2. Okay. 11 we did already. So let's go ahead and look at 12. Again, we're going to call this y for g of x. Swap it. So it'll be x equals negative 4y plus 1. This one should be pretty straightforward. Okay. And go ahead and subtract 1. So it'll be x minus 1 equals negative 4y. And divide both sides by negative 4. So we will end up with x minus 1 over negative 4 equals y. Okay. And you can put the negative in front. You can put it on the top or you can put it on the bottom. I'm going to put it in the front. So we're going to go ahead and say g inverse of x is going to equal negative x minus 1 over 4. Okay. And the negative is I'm putting it in front. You can move it to the top if you like, or you can move it to the bottom like how we had before. Either way is fine. I am just putting it in the front. Okay. 13 we did. So 14. Call that y. Okay, swap x and y. So x equals y plus 3. Oh, this one's pretty quick. This one's going to end up being x minus 3 equals y. Right, so that means that our f inverse is going to be x minus 3. Okay. Same thing here. Call that y. Swap x and y. So it'll be x equals negative y plus 3. This time around, I'm going to go ahead and add y to both sides. So it'll be x plus y, because I want the y to be positive, equals 3. Then I'm going to go ahead and subtract x. So it'll be y equals 3 minus x. Or you can call it negative x plus 3. Okay, that just seems like it's a little sloppy. So I just wrote the minus x in the back. And there you go. That's your finale. So that would be the inverse f negative 1, which is f inverse. It's going to be 3 minus x. Okay. This one, again, it's a y. Swap it. So it'll be x equals 4y divided by 4. So it'll be y equals x over 4. So that means the f inverse is going to be x over 4. Okay. Or you can call it 1/4 x. Okay. Either way is fine. So you can write it like that, or you can write it like that. Depends on how you like it. Okay. So that was just finding inverses. Let's go back to the beginning. Numbers 1, and I didn't have you guys do 2, 4, 6, or 8. Okay, I actually erased those, so you don't even see those on your assignment. But say the given inverses are functions are inverses. So what needs to happen? Actually, I may need some space. So it's probably a good thing that I give you guys lots of space. Lock in place. One more. Lock in place. Okay. So to find this, we will need to start with our f function or g function, doesn't matter, and we're going to put g in there. So we're going to do a composition. So f function is going to be 1/2 x, but instead of x, I'm going to put g in there, plus 3/2. Okay, so the g function is 4 minus 3/2 x. Right, and like how I was telling you guys, if it's going to work out, remember, because if it's going to work out, you need to get an answer of x at the end of the day. So if it's going to work out, it should slowly start to work out. Okay, so 1/2 of 4 is going to be 2, and 1/2 of 3/2, so minus, is going to give us 3/4 x, and then plus 3/2. Ooh, let's see what this makes. So I'm going to pull up my calculator. Okay, let's go ahead. Let's use the calculator to help us. Let's figure out what 2 plus 3/2. And this may not work. Let's see. It doesn't look like it's going to work. But 2 plus 3/2, just like that. That gets us 3.5. Okay, and there's no way we're going to be able to get just an x from that. So our final answer is going to be not x, but 3.5. Okay, and 3.5 in terms of fraction is 7/2. So what do we get? We get 7/2 minus 3/4 x, and that's our final answer. And because that's not just an x, we can stop there. Right? We don't have to go any further. We don't have to do the other way around, the g of f of x. Because even if this somehow comes out to be x at the end of the day, the f of g of x, the first way we did it, doesn't come out to be x, which means that they're not inverses anyways. Okay, so we don't have to do it the second way, and we can say not inverses. So not inverses. Okay. Let's try this one. Let's take our f, and we're going to put g of x in there, or g of n in this case. So function f is negative 16 plus n, and n is actually, here, I'll write this, 4n plus 16. This one may work out because you can kind of see it starting to work. Okay. So what happens? Well, first I can erase the parentheses because that plus is not going to affect anything in there. It's going to keep the same. And what can I do? I can put a negative 16 and positive 16 together. So I will have 0, right? So I will have 4n over 4. And from there, I can go ahead and cancel the 4's out. And lo and behold, I get n, which is the same as x. Okay. Now, because that works, I have to try this the other way, which is g of f of x. Okay, so g is going to be this bottom function, so it'll be 4n plus 16. Okay, and instead of the n, I'm going to use the f of, n. I keep using x. That should be an n. right? So instead of 4n plus 16, instead of n, I'm going to use f of x, which is this. So I'm going to put in negative 16 plus n over 4. Okay, and we'll see what we can do. So when we work this out right here, we can cancel these. So we're left with negative 16 plus n plus 16. And you can see that, negative 16 and positive 16 cancels, and we are left with n. Okay, so this one we can say that these are inverses, because they both equal n, or x in this case. Okay, so we're going to start with f. I'm going to put g of n in there. Okay, so we're going to go ahead and copy the function f, negative, and then instead of n, I'm going to put in 3 plus n to the third power, and then plus 1 to the third power. So what does all this make? Well, all of this makes, let's see, well, the parentheses means, and I got to work in there, but nothing can be done to it, so I can erase that, and therefore I can add 3 in the 1. So I have a negative 4 plus n to the third power to the third power. Okay, I don't know what that makes. Well, I know what it makes, but it's not going to be equal to n, right? So we can just kind of leave it like that. Okay, and that's kind of pretty much our answer. We can expand it a little bit more, but we'll actually learn how to do that, or you can do it by hand, but that's definitely not n. So I'm going to say these are not inverses. Okay, because when we do f composed with g, it doesn't work. We don't have to proceed. Okay, let's try this one. Again, let's try again. F composed with h of x. So the f function looks like 4 over, and I'm looking right here, 4 over negative x minus 2 plus 2. No, you cannot add the plus 2 minus 2. Okay, and inside that x, or inside that parentheses, I'm going to put in negative 1 over x plus 3. I don't think I can do much here. Doesn't look like I can do anything, but you never know. Okay, so we'll do a little bit of work. Just a little bit. So 4 over, I have a negative and then negative, so it'll be just be positive 1 over x plus 3. That's a fraction on the bottom. Minus 2, and I'll put a 2 over 1. Common denominator of x plus 3. Which means I need x plus 3 on top also. Oh, and then don't forget the plus 2 in the back. So I hope this works, because it doesn't look like it's going to work. Let's see what's going to happen. So we have a 4, 1 over x plus 3, minus 2 times x is 2x, 2 times 3 is 6, so plus 6, and then over x plus 3, plus 2. I need some more space, which means I'm going to get rid of some of this stuff down here. I need actually more space. Let's see. Okay, so I get 4 over, and then since they're both x plus 3, I can combine that. Okay, so let me look. I have a 1 and a minus 6. So 1 minus 6 is actually negative 5. And then I have also a negative 2x. So I'm going to write down minus 2x. And then plus 2. Okay, so I don't think this is going to work. I don't think. And whatever I do to this, it's not going to work out to be where it's nice. I can fix this by rewriting this. And it's going to end up looking like 4 times x plus 3 over negative 5 minus 2x plus 2. But again, by combining it and doing some work to it, it's not going to give me an x. So it's not going to equal x, which means that I know that these are not inverses. Okay. Okay, and then the last set. And we did 19 and 20 in class, so we're just going to go ahead and do 17, 18. And we're going to find the inverse of each one. Okay, so call that a y, swap it, so it'll be x equals negative 1 minus 1/5 y. Okay, I'm going to go ahead and add 1, so it'll be x plus 1 equals negative 1/5 y. I'm going to swap these around. So I'm going to move the negative 1/5 y to this side, so it'll be 1/5 y. And I'm going to move the negative x over, so the x over, so it'll be negative x. And I'm going to move the 1 over, it'll be minus 1. And then I'm going to multiply both sides by 5, just to get rid of that 1/5. Oops, I'll delete it. I'll erase it. So multiply both sides by 5, which will get me, finally, y equals negative 5x minus 5. Right? And let's graph both. Okay, so that's going to be my inverse. So instead of f of x, that's my inverse, and I'm going to call that f inverse, f negative 1 of x, negative 5x minus 5. Okay, so let's graph them, and we don't actually even need a calculator on this one. Okay, so this first one here, we'll put that in blue. So f of x, we'll put that in blue, and then negative f of x, or sorry, f negative x, f negative 1 of x, which is the inverse. Okay, so to graph this, we're going to start with negative 1. The slope is down 1 over 5. Okay, and that's your slope. So down 1 over 5. So down 1, 1, 2, 3, 4, 5. Okay. That right there is my line. Okay. To grab the second one, we're going to start at negative 5. 2, 3, 4, 5. And it's going to go up, or it's going to go down 5 over 1. So 1, 2, 3, 4, 5 over 1. That's kind of hard because it's not on there. But what we can do is we can do the opposite, right? We can also go up 5. 1, 2, 3, 4, 5, and then to the left one instead. So we can actually do that. And you can see that these 3 dots, and I just kind of winged it down the bottom, but they will be on the same spot. So, but this one right here, because there's no actual points, it's kind of hard for me to kind of make sure that it is the correct spot. So I'm going to use the up 5 and over 1. Okay, so we're going to go ahead and do the same thing. Here to here. Okay, and how do we know it's a how do we know they're inverses? Well, if they're inverses, you should be able to do a perfect diagonal line, like from the 0, and then it hits the corner, and then it goes through all of that too. It hits every single corner, and it's just split right down the middle. So we know that those are perfect inverses of each other. This is f of x, and this is f inverse of x. Okay, and that does come out perfect. So what we found is actually correct. Okay, let's do one more. I'm trying to hit under the 30 minutes because when it's 30, when I upload to YouTube, it actually takes a little longer. Or actually it doesn't work and I have to upload it through some other method. So this one actually, it's going to be a little weird. So I'm going to go ahead and graph that first. Okay, so use the calculator to graph that. So what does that look like? That's going to be a 1 divided by x minus 1. If I graph it, okay, so it kind of looks like it has an asymptote at the positive 1. So it looks like this. Kind of like that. Double checking it, yeah. Okay, if I do a zoom 6, you'll see it. Okay, that middle, the line that goes up and down, that's just a asymptote. So, okay, let's go ahead and figure out the inverse. Okay, so I'm gonna go ahead and put an x, put a y. So swap it, so it'll be x equals 1 over y minus 1. Let's go and flip both of them, right? And that's a strategy. I mean, I taught you guys how to multiply by y minus 1 on both sides, but another strategy is you can actually flip both of them, meaning that you can take this x, put it as x over 1, and flip them because we want the y to be on top. So we flip them, we'll get 1 over x equals y minus 1 over 1. And in this case, we don't actually need to have the 1 on the bottom. And then from here, we just add 1 to both sides. So we will finally get our answer of y equals 1 over x plus 1. Okay? Or the inverse of g of x, so g negative 1 of x, is equal to 1 over x plus 1. Okay? By doing that, I actually did it really quickly instead of going through, multiplying both sides by, y minus 1. Okay? And either way works. So that's our g of x. We already did that. We already graphed it. And let's look at f of x, or g inverse of x. So that's in 1 divided by x plus 1. Okay? And because I didn't put parentheses around it, it's going to keep them separated, kind of like how we have it here. We graph that. Ooh. So this one looks like it follows a 1, and then it kind of goes down here. So it kind of does this. And then it's going to come back up. Yep. Not too much. Okay. And if we draw our diagonal, let's check it out. You think it'll hit it right through the middle? I think so. Okay, so I'm going to go right on that diagonal through that. You see it? Kind of hits it right in the middle.